Hi, my name is Trevor Johns. I'm a developer programs engineer on the Android team. Let's take a bit to talk about how to do network service discovery on Android. So, what is network service discovery? So say that you have a game and you want to let friends play with each other. One approach is to get email addresses for everyone in the game and use that to set up a shared room on a server somewhere in the cloud. It's not a bad approach, especially if you're going to be competing with someone far away. But if all your friends are sitting right next to you, all those email addresses are going to get a bit inconvenient. Wouldn't it be great if you could just find nearby users who also happen to have your app, just based on the physical proximity? This is where Network Service Discovery, or NSD, comes into the picture. NSD lets your app find other devices on the local network that support services you're interested in. Those services could be physical devices like printers, webcams, HTTP servers, and yes, even games. In a sense, it turns any local network into a social network for apps. Take this game here, which uses NSD to place everyone on the same subnet into a virtual waiting room, as a quick way to form teams. Once discovered, you'll then be able to connect directly to any of those apps using the standard Android networking stack. So let's go into a bit more details about how all this works, and then I'll show you how to implement the code for all of this inside of your app. NSD is based on two protocols, DNS-SD and multicast DNS. The SD stands for Service Discovery. Like DNS on the internet, this provides a mapping between human-friendly hostnames, so say myphone.local, and the IP address where that device lives. Now normally you'd go to something like google.com. In this case, everything is going to be ending in something.local because it's on the local subnet. That's how the device can distinguish between devices advertised via multicast DNS and devices advertised using the global DNS system. So, unlike traditional DNS, MDNS is completely distributed, which means no central server. Devices communicate amongst themselves to build a network directory of services. Since it's based on multicast, it only works between devices on the same broadcast domain, so such as a LAN. It also requires that the network supports multicast traffic, which some businesses or university networks might disable. But it should work without problems on most home networks or even small business networks. DNS-SD extends multicast DNS to provide service discovery, listing what hosts implement specific protocols. Many people think of DNS exclusively in the context of mapping host names to IP addresses. But DNS is actually a general, if somewhat limited, hierarchical database. It can store almost any kind of data for almost any purpose. So, service names in this case will take the form of service.transport.local. This is how we're mapping from a service name to what you traditionally think of as a domain name. So in this case, we're using myapp.tcp. Myapp is the service name, and TCP is the network transport that we're using. Clients can then go and query on this name to retrieve the listing of devices supporting it. Once a desired device is selected, the IP address, port number, and any other necessary metadata are requested via DNS service or SRV records. Since we're using multicast DNS rather than the usual internet DNS infrastructure, there's no need to go and register these domains with any registrar or pay money. You can just simply broadcast them to network peers as they're needed. Now that said, it's still a good idea to register your service name with the IANA to prevent any name collisions. There's a free service on iana.org that'll let you do this. Now that we've gone over the protocol details, let's talk about using the NSD APIs on Android to broadcast your app's custom service. The good news is you don't need to worry about most of the protocol details since the OS takes care of almost everything for you. So before you start, let's say that we have our app listening on an available port. This is just the code that you typically use to open up a socket on Android. But notice that we're not explicitly selecting a port here. Be careful to never hardcode your port number when you're using NSD, since other apps could be using the same port number as your app. Instead, we'll ask the system to give us a random, unused port. This is okay though, because we're going to go and advertise this to other devices, so they'll be able to discover which port you're listening on. So, now that we have a service listening for traffic on our device, we'll want to register that on the local network. The first thing to do is to create an NSD service info object. This object provides all the information that other devices on the network will use when they're deciding whether or not to connect to your device or not. The service type, again, uniquely identifies the service your phone is advertising. So something like appname.tcp, and you'll typically put an underscore in front of each section as a matter of convention. The service name uniquely identifies a particular instance of your app. So this is not the service type, the service name. Now, with the service name, it's usually a good idea to use the device's Bluetooth name, just as something that's nice and human-friendly. It should be unique, but if not, it's not a big deal. Android will go and append a number to the end of the name to correct that error. Finally, we'll set the port number that we selected above, so that other apps know which port we selected. Calling register service, finally, will inform the OS about the new service, and Android will take care of broadcasting that information out to other devices as needed. At the end here, there's a registration listener, which is a set of callbacks, like on-service registered, that'll let us know about the success or failure of this operation. We're going to see this pattern a lot over the next few slides. The important thing to notice here is on-service registered, which is where our app can go and store the service name. Even though we set this when registering, the OS might have changed it to resolve a conflict from another device on the network. Remember, I said that the service name always has to be unique, so this is your chance to go and discover if it wasn't and update your UI if needed. You might want to go and show the service name to the user. Not all apps do though, so this might or might not be of interest to you. Now that our app is registered, let's take a look at how to issue a query to find other devices. Service discovery, like service registration, has two steps: setting up a discovery listener with the relevant callbacks, and making a single asynchronous API call to discover services. Let's work backwards. We'll start with the call to discover services. Here you'll pass in the service name that you're interested in, so again something like myapp.tcp, the name of the discovery protocol to use, which is always DNSSD. Again, this is not the protocol of your app, it's the service discovery protocol. And right now Android only supports DNSSD, so this argument will always be protocol DNSSD. And finally, a discovery listener object, which is what we'll use to get the results of this discovery process. The listener will get a callback for each device found, and of course there's callbacks where your app can handle any errors found. The important method here is onServiceFound, which is where we're going to find about all the services and devices that we're potentially interested in and store them in a list. This is the list that you'll typically present to the user, and that will let them pick which devices that they want to connect to. So once we know which devices we want to connect to, we call resolve service. This is another asynchronous call. It's a little bit expensive, so again, we have a listener that's going to go and get the results of this. And this is where we find out the IP address and port number of the device that we want to connect to. Once you get that information, then we're just going to go ahead and connect to it directly using a standard socket. Now, before you go off and play your game, there's one last thing you'll want to do. When your application exits, it's very important to unregister your service so that the OS will stop advertising it to other devices. To do this, call NSD Manager's unregister service method whenever your application's onDestroy or onPause method gets called. You'll also want to make sure to call stop service discovery, since the discovery process is also a bit expensive and we don't want to leave that running unchecked. And that's it. You're all set to use network service discovery to find other copies of your app on the network. Happy networking.